This is Subhash Reddy from IITG Coaching Center, Gauridoddi. Today we are going to discuss binomial theorem in the G-mains point of view. What are the important concept and questions based on that. So here I just wrote 1 plus x whole power n. This is the binomial expansion. This short form is what is very important. So in short form, what we take is summation NCR x power n minus r y power r. This is what is r plus 1th term, general term. So that means if you substitute r equal to 0, 1, 2, 3, so on up to n, then you will get all the terms. So this is short form of writing, which is very important. And then x minus y whole power n is what? Minus 1 to the power of r NCR x minus r y minus r. So this is, that means alternate plus minus will come. So this is most importantly, we use many of the questions this formula. What is that? 1 plus x whole power n is summation r equal to 0 to NCR x power r. Very simple one. And 1 minus x whole power n is this one. So now many of the questions are asked based on this only. So now let us see one question. You see one question here. The coefficient of x, t power 24 in 1 plus t square whole power 12, that just you see that and try to solve that. So that is actually very simple question, if at all. Okay, so this is very simple question. Then I am going to write only required steps. That means we are going to take only 3 or 4 steps. Within 2-3 steps you are going to get the answer. So what is the question? T power 24 coefficient in what is the expression 1 plus t square whole to the power of 12. Here 1 plus t power 12 into here the next 1 plus t power 24. So here I am going to explain very important points that you need to observe in solving each problem. So in this we need to find out t power 24 coefficient. So therefore what we should do is 1 plus t square whole power 12 you need to expand. So this one depending on what are the terms you get here. So what are the terms you get? 1 plus t power 12 plus t power 24 plus t power 36 you get. That is not required, therefore you need not write that. So the next one is here, what we need is t power 24 coefficient. So this expansion, you know, summation r equal to 0 to n, here t square whole to the power of r. That means here this one we have to multiply with this. Since this one should be multiplied to here to get t to the power of 24 coefficient, this one should be multiplied to what? T power 24. So t power 24, how do you get here? 12c 12 t square whole to the power of 12, right? So this one should be multiplied to this term, and this one t power 12 should be multiplied to t power 12. When do we get to t power 12? R equal to, you have to substitute 6. So that means 12c 6 t power 12 you get automatically, t square whole power 6 you get. And this one you have to multiply with what? This one you have to multiply with just 1. So that 12c 0. So therefore what is t power 24 coefficient is this one. So this is 1, here you get 1. So plus here 12c 6 plus you get 1. So therefore t power 24 coefficient is just 12c 6 plus 2. See, just here we did not write all the expansion and all. Whatever terms are required to be multiplied, only those terms we wrote. So that means here 1 for 1 what we need is t power 24 we need. So t power 24 coefficient is 12c 12. And here for t power 12 what we need is 2 power 12 we need. So therefore we only multiplied 12c 6 t power 12. So that means here even though you have 13 terms, we wrote only 3 terms which you need. So that you can save lot of time. So therefore here this one we got. So but here by practice what do you get is, so this one is there. By practice I am telling. So here only one step. Here you know how many terms you get? 13 terms, out of which this one should be multiplied to 12c 12 t square whole power 12 will come automatically. This one should be multiplied to what? This one should be multiplied to t power 12. So that one is here 12c 6 t square whole power 6 automatically will come. Here till 12c 0 you have to multiply. If at all you know this formula, simple formula, so you can answer very easily. So this into this 1 plus this into this is 1 into this 12C6 plus this 1 into this is 1. So simply 2 steps you will get the answer. Okay, now let's go to second question now. So this is very interesting question. Just you see that. Very interesting question. So here, now I gave you hint for this problem. So in the first problem only I gave the hint for this problem. What is that? 1 plus x into. So this is 1 plus x into 1 plus x square into 1 plus x cube into so on up to 1 plus x plus so on up to x to the power of n. This is given as, so this is given as a0 plus a1 into x plus a2 into x square plus 1 into an into x to the power of n. Like this it is given. So of course here m is given, am x to the power of m is given. Okay, so what is the question here? Then value of a1 is. So here value of a1 is what is the question? What is a1 is the question. So now here simply you see you want what you want is a1, that means x coefficient you want. From LHS you have to just find the x coefficient. So how do you find x coefficient in this? So like previous question I told, here simply you need to write 1 plus x here, 1 plus x square is not required, because if you multiply x square with any of these terms you are going to get x square and higher degree variables you are going to get, which we don't need. Just you need x coefficient. Therefore x square can be neglected. Then here also x square can be neglected. X square and higher terms can be neglected. So on up to here also you can neglect x square and higher degree terms. So here this is just how many terms here? 1, here 2, then 3, 4. So if at all you see now 1 plus x whole to the power of n product of n, this is n 1 plus x are there. So here what you need to 1 plus x whole to the power of n, here you need to find out just simply x coefficient. That means what? nc1 into x. Therefore your answer is n. So for this, so here what are the steps you need to write is, here just by seeing the question x square and higher terms are not required. Therefore 1 plus x here 1, 2, 3 n. So whole to the power of n. Here x coefficient is what you need to find. What is x coefficient in this is x coefficient in this. So that is nc1. So that is n is your answer. That simple it is. So if at all you understand this. Okay, now let's go to next question. These are all previous GMains questions. So this is very interesting question. So you can answer it in 2-3 steps if you know it properly. So here what we have is 1 plus x whole to the power of 2016 into x into 1 plus x whole power 2015, so on you have. So now, so in this question, so I am not going to write the question, because here this question, just by seeing this question you can understand this is GP, geometric progression, with how many terms? 2017 terms. So therefore, so what is here? This is given as summation. So here r equal to, I am writing I as r equal to 2016, 0 to 2016. That means 2017 terms are there. ai x to the power of I, that means ar x to the power of r. I am writing wantedly r I am writing I as r I am writing because r is very familiar to us. So here a17 is what is asking, a17. That means here a17 means what? a17, that means r equal to, you have to substitute 17, x to the power of 17. Indirectly is asking x to the power of 17 coefficient in LHS. So what is LHS? Just by seeing LHS you should remember this formula. What is the formula? X to the power of n plus x to the power of n minus 1 into y plus x to the power of n minus 2 into y square plus 1 up to x to the power of 0 into y power n. This formula you need to remember. This formula is there in limits also, we use this formula, and many other places this formula is very important. This is GP only, x power n plus 1 minus y power n plus 1 by x minus y. If you know this formula, one step problem. What is that now? N plus 1, 1 plus x, this is x. This is x is 1 plus x all to the power of n plus 1 is 2017. This is what is n plus 1. Minus y, y is what? X, x to the power of 2017 by 1 plus x, this is x minus y is x. So therefore this and this gets cancelled. Now in this what you need to find? x power 17 coefficient in this. In this x power 17 coefficient is 2017 C17. Very clearly. This one you know. So NCR. So 2017 factorial by n minus r factorial 2000 factorial into 17 factorial. You know this. So this simple it is. That means just by seeing you write this step and then from this you immediately recognize the answer. That means only one step you write. So okay, all right. So this is hope you understand. This is just GP. And now if you understand this problem, you can answer. So what is the next problem? You can answer this problem. So now this problem, fourth, is previous G-mains question only again. So just by seeing, I told you have to write this. What is the formula? 1 plus x whole to the power of here 1000 is there, therefore 1001 minus x to the power of 1001 by 1 plus x. This is x minus y. So this gets cancelled. Now question is x power 50 coefficient in this. In this x power 50 coefficient, what is x power 50 coefficient? 1001 C 50. This is what is x power 50 coefficient obviously. So this is what is your answer here? So C is your answer. So that means what? Only just by writing one step you recognize x power 50 coefficient. So this is how you can answer very easily if you know this formula. Okay, again next fifth question, very interesting. You just see the question. So what is that? 1 plus x power 4 plus x power 5. So this is the question. Just observe this question. This very very important logic is there in this question. R equal to 0 to, I am writing just 5 ai into 1 plus x whole power I. I is there in the place of I. Let's write R so that it will be easy. So now what you need to find out? A2 you need to find A2. So if at all you expand this one now, so this is A0, x power 0 is 1, A1 into 1 plus x, here A2 into 1 plus x whole square plus 1 you get. That means I am writing 1 plus x whole cube also I am writing plus 1 will be there. What you need to find out? A2 you need to find out. If at all you do it directly. That means what? Comparing coefficients of LHS and RHS. It's going to take a lot of time. So therefore we are going to apply a logic here. Two ways you can do. Method 1 I am telling. So very simple. Replace here one understanding. Replace x by you have to replace x by y minus 1. So here what you get? 1 plus this is y minus 1 whole power 4 plus y minus 1 whole power 5. This is nothing but here I am writing. Just here only you can write this summation r equal to 0 to 5 here a r into 1 plus y minus 1 whole power r. Simple C here. Now what you need to find out? A2. A2 is nothing but what? A2 is nothing but y square coefficient. So what is y square coefficient here? Y square coefficient, because this equal to this y square coefficient in this, y square coefficient in this. What is y square coefficient in this? Here no y square, here y square is there, 4c2 y power 4 minus 2, y square coefficient is this, minus 1 to the power of 2. Next plus here 5c2 y square coefficient is 5 minus, this is 3, 5 minus 3 is 2 minus 1 power 3. So this is what is y square coefficient. We need to find out, that is 4c2, 4 into 3 by 2. So that is 6. Here next minus y square coefficient is 5c3 is nothing but 5c2. What is 5c2? 5 into 4 by 2, that is 10, which is minus 4. So that means if you know the simple trick, so just one step answer. So if you know the simple trick, then you need to substitute here y minus 1. So minus 1 plus 1 gets cancelled. Y power r. So that is AR y power r. So you need to understand that. Now here question is A2 you need to find. So A2 is nothing but y square coefficient. So what is y square coefficient here? Y square coefficient here you need to find. So that is what is this. This is one method, and another method is there. So then another method, very interesting method is there, another method. So what is that? Applying derivatives. Some of the questions like this, if you apply the derivative it will be easy, but applying derivative possible only when you need to find out either A1 or A2 or A3, not the higher degree, because you need to differentiate on both sides. So to find out A2, what you should do? you need to differentiate. If you differentiate one time, 4x cube plus 5x power 4, and this side if you differentiate, this is 0. If you differentiate, this is a1 into this is 1 plus this a2 into 2 into 1 plus x plus a3 into, I am writing this 3 into 1 plus x whole square, and plus 1 you are going to get. Here one more time differentiate one more time. If you differentiate one more time, what you are going to get here? 12x square plus 20x cube equal to, this one is again 0, this is 0, this is also 0, a2 into, this is 2 into this is 1 plus a3 into 3 into 2 into 1 plus x, plus then remaining all the terms will have 1 plus x. So here now what you need to do is you have to make all these zeros. To make all those zeros, x equal to minus 1 you have to put. If you put x equal to minus 1, this is 12. If you put x equal to minus 1, this is minus 20. This is 2a2, and remaining all the terms will be 0. That is the idea here. So this is very important trick. 2a2 is minus 8. So then a2 is minus 4. So that means just within 2-3 steps you are going to get the answer. So now let's go to another question. Next go to another question. Now here number of terms. So just see the question. You need to find out number of terms. So now so in binomial, I just wrote the binomial expansion. So in binomial expansion, you know 1 plus x whole to the power of n, how many terms will be there? N plus 1 distinct terms will be there. So this number of terms will be asked very frequently. So this number of terms concept is very important now. So this is n plus 1 terms will be there. Now I am going to write one simple question here. Here you need to find 1 plus just x plus 1 by x, let's say whole to the power of, just I will write 100. Number of terms in this. And one more question, a plus b plus c plus d is there. Here whole to the power of some 100 I am writing. So number of terms here, or a plus b plus c whole to the power of 100 is there. Number of terms here. Let's first see this questions. Here number of terms is 100 you have to distribute to 4 terms. Number of distinct terms you need to find here. For finding number of distinct terms, 100 you have to distribute to 4. How many ways you can distribute 100 to 4 terms? 100 plus 4 minus 1, c 4 minus 1. These are the total number of distinct terms in this. In this similarly 100 plus 3 minus 1, c 3 minus 1. These are the number of terms here. But here number of distinct terms you are finding by using this formula. What is that? N is there. This is, let's say, n. Here let's say these r terms are there. N you have to distribute to r terms. N plus r minus 1, c r minus 1 is the formula. So now here you cannot use that formula here everywhere. Just one formula everywhere you can't use. You have to see the context. Here 1 plus x plus 1 by x whole to the power of 100 is there. Number of distinct terms you need to find. So number of distinct terms you need to check here. Highest power is x power 100 will come, and lowest power is 1 by x power 100. So middle x power 0 will be there, x power 1 will be there, x power 2. That means here 100 terms will be here, here one more 100 terms will be here, and middle one term is there. So therefore 201 number of terms will be 201 number of terms will be there. So like that you need to answer this kind of question. So similarly here x square plus 1 by x square whole to the power of, let's say, 200 is there. Number of distinct terms in this. You cannot use formula here because here all the variables are, here only one variable is there, x is there. So therefore some of the like terms will be there, those like terms will be added up. Therefore what you need to use? Minimum power, maximum power. Minimum power is x to the power of minus 200, maximum power is x to the power of 200, middle x power 0 will be there, and terms will be like this. What? X square, x power 4, like this. You will not get x term, x cube term will not be there. So therefore these are how many terms like this? Only even powers will be there. 100 terms here plus 1 term is this, and here one more 100 terms will be there. So total 201 terms will be there. So this is a very important concept. Okay, now what is the question there? You see what is the question there? Now this question is asked in G-Mains. Number of terms in this expansion: 1 plus x whole to the power of 100 into 1 minus x plus x square whole to the power of, this is 101 and this is 100. In this you have to find out number of terms. Okay, when you expand this, when you expand this in powers of x, so that means you need to find out number of distinct terms. So how many distinct terms? First thing is, many of the questions you need to rearrange things. When you write rearranging like this, 1 plus x you keep aside, here what will be there? 1 plus x whole power 100 will be there, into this is 1 minus x plus x square whole to the power of 100. Now I am writing common 100. Common power I wrote. So this is the rearrangement which is very important. So here 1 plus x into this is 1 minus x cube, a plus b into a square minus ab plus b square, a cube minus b cube whole power 100 is as it is. Now here how many terms will be there? So very simple, here 1 into this thing, so that is 1 minus x cube whole power 100 plus x into 1 minus x cube whole power 100, like this. So here what are the terms? Terms will be in powers of 3. So that means what? C0 minus C1 into x cube plus C2 into x cube whole square, like this. So that means here obviously you all know that here 101 terms will be there. Plus here whatever terms you are getting in multiples of 3. That means here you are getting x cube, x power 6, x power 9, like that. So here this is 1, plus here the terms you get is for the same expansion you are multiplying x. So when you multiply x, what terms you are going to get? X minus nc1 into x power 4 plus nc2 into x power here see 6 plus 1 7. See, you are multiplying x. So that means here multiples of 3 you get. Here powers will be multiples of 3 plus 1 you are going to get. So therefore here 101 terms will be there, plus here also you are going to get 101 terms. Total 202 terms will be there. So very logical question, but very simple question, but at the same time it's very logical question. Okay, this is a number of terms if you write in powers of x. So now let's take this is another question. Okay, so now you see this is number of rational terms. So here this is a very important model, that is x 2 to the power of 1 by 2 plus 3 to the power of 1 by 5 whole to the power of 10 is there. This is the one question. You need to find out some of the rational terms in this question. So next question is number of integral terms in the expansion. So I am writing here another question, that is this is 3 to the power of 1 by 2 plus next 5 to the power of 1 by 8 whole to the power of 256. So now I wrote just 2 questions here. So here what you need to find out in these questions now, you need to find out number of integral terms. So in this number of integral terms are number of integral terms or rational terms. Rational number of integral terms or rational terms is same. So what is, how do you find number of integral or rational terms? Very simple. Here NCR x to the power of n minus r, that means 1 by 2 whole to the power of 256 minus r. Just I wrote shortly, this 3 I did not write, actually 3 power will be there. This 5 power 1 by 8 whole to the power of r means here you get r. So you need not write this, because you need not write this one, you need not write. Only powers we need to deal with, because here 2 should be cancelled out. So your first thing you should do is LCM. 2 and 8 LCM is 8. 256 you have to divide by 8. You are going to get 32. You are going to get 32. So here plus 1 term will be there or not is the question. Now exactly 32 terms or plus 1 term is there is the question now. Here what you need to check, you have to, 2 things you need to check. One is r equal to 0. If you put r equal to 0, now it is getting cancelled with 2. Now this also. So that means what, here you are going to get a rational term for r equal to 0. So therefore you need to add 1, that's it. So that means if at all, let's say now r equal to 0 is not giving you rational term, then what you should do is you have to go for last term 256. That means first 0 and last term, that is 256, you need to substitute and check. So then you are going to get only extra 1 term or not, for that you need to check these 2. Then here 33 either rational integral terms you call or rational terms. So here first is this. Next here irrational terms, number of irrational terms. Let's say you need to find out irrational terms. So here 256 plus 1, total number of terms is this minus number of integral terms is 33 or number of rational terms is 33. So, remaining terms you are going to get is what is irrational terms, number of irrational terms. So, this is first you need to find out LCM, divide by LCM, and then you need to check whether plus 1 will come or not. That means if it is r equal to 0 is giving you rational term, then plus 1 you will get, or r equal to 256 last n is giving you rational term, then also you will get plus 1, otherwise plus 1 you won't get. So, here r equal to 0 is satisfying, therefore we can stop there. So, then otherwise you have to check for last 256 also. So, this is what is the question here, total 33 terms. Now, what is previous question here? Here sum of the rational terms, just here what is the LCM 2 comma 5, LCM is what is 10. You need to divide 10 with 10, that means 1 you are getting, that means 1 is for every 10 terms you are getting one rational term. So, now here what you need to do, you have to put r equal to 0 and check for what. So, for 2 to the power of this expansion is what, 2 to the power of 1 by 2 n minus r, 10 minus r, and 3 to the power of 1 by 5 whole to the power of r. So, now here r equal to 0 is giving you what, a rational term, r equal to 0, that means what, 10c0 whole to the power of 2 to the power of this is 5 and this is 3 to the power of 0, r equal to 0 is what I substituted. So, this is what you got, 1 r equal to, then after 0 here LCM is 10 is there, LCM is 10, this LCM is 10, therefore for every 10 terms you are going to get one rational term, therefore here r equal to 10 is next. So, 10c10 here 2 to the power of this is simply you can substitute this is 0 and next 3 to the power of 1 by 5 whole to the power of this is 10. So, that is this is what is 32 plus this is what is 3 square. So, that is 9. So, total 41. Hope you understand. So, here for every, here I told you for every 10 terms you are going to have one rational term. So, here for r equal to 0 it is satisfying. The next rational term will be r equal to 0. R equal to 0 I substituted. So, that means 10c0, this is x to the power of, this x to the power of n minus 0, that means 10 minus 0, 10 by 2, this is r power 0 is this, and then 10c10, right, this is 10 I substituted, this is 0 and this is square will come, 3 square is 9. So, therefore, this 41 is the sum of rational terms in this binomial expansion. So, now this kind of easy questions will be there. This is degree of the polynomial, that means what, just you need to use the binomial expansion this. So, that is easy one. So, now here you see sum of the coefficients of integral powers, again same. So, very interesting question again. So, sum of coefficients of integral powers of x in the expansion of 1 minus 2 root x whole to the power of 50. So, here we are going to solve very simply. Here what is asking is sum of coefficients of integral powers. For this you should get integral power. So, root 2 whole power 0, root 2 whole square, that means even power will cancel out this root. Therefore, even power coefficients we need to find out. That means here C0, so this is first 2 root x whole power 0 plus, this is what is asking, C2 2 root x whole square plus whole power 4. This is what is asking. He is asking integral power, that means this is integral power, then root x whole to the power of 4 also integral power, that is integral power. So, now here sum of the coefficients of integral power. What are the sum of the coefficients? So, that is 50c0 plus 50c2, 2 to the power of 2, 50c4, here 50 is there, we need not write that, 2 power 4 plus 1 up to c50, 2 power 50 is what is the question. So, for this directly if at all you understand, so what is this, 1 plus 2 whole to the power of 50 expansion, 1 plus 2 whole to the power of 50 expansion added up with what, 1 minus 2 whole to the power of 50 will give you twice of this, therefore divided by 2. Simply this is what is your answer. So, you can answer like this. So, that means first step itself is this one. So, if at all you understand the question, Here integral powers means what? Square, power 4, power 6 should come. Therefore, directly write 50c plus 50c2, then 50c4 and 50c5. Like this you are going to write. So what is this? So 2 square 2 power 4 means what? nc to x power r. We already saw NCR x power r form is there. So 1 plus x whole power n. So in that only even powers are there. So therefore 1 plus x whole power n plus 1 minus x whole power n is what will give you this one. So therefore this is twice will come, therefore divided by 2. So only 2 steps you can answer this one. Okay, so now let's see here one very important thing here, last one. So that is here we need to find out k, given that coefficient of x in the expansion is, so what is that? X square plus k by, here this is x whole to the power of, this is what is 5. So here what is given is x power 1 coefficient, x power 1 coefficient is given as 270. Then we need to find out the value of k. So this kind of questions, independent term, x power 1 term, x power 5 term. So in this we have a very simple formula, that is np, 5 into p, np. So in this ax power p plus b by x power q whole to the power of n. Here to find out x power k coefficient, what is the formula? np minus k by p plus q. So if you use this formula, it's going to be very simple. 5 2s are 10. So right, this is 5 into 2 minus 1 by p plus q is 3. Therefore 9 by 3 3. So r is 3. So 5c3 x power 5 minus 3 and k to the power of 3, right? So this is what is given as 270, right? So coefficient of x in this is 270. So here 5c3 is 5c2, 5 into 4 by 2, that is 10 into k cube equal to 270. So from this very clearly k is what is 3. So very simply you can answer this kind of questions. So next question also same like that only. The ratio of coefficient of x power 50 to the term independent of x. So that's also same model. So like this binomial theorem you can answer very easily in GMains or advanced or MSET. You can answer actually any question you can solve in 3-4 steps only. Very easily you can solve if at all you are actually we solved only questions based on very simple concept, that's expansion only we solved. So otherwise any question you can answer just in 3-4 steps only you can answer. So okay, here x power 15 coefficient to independent term in this expansion, x square plus this is 2 by x whole to the power of 15. Here 15 coefficient and independent term, so you can answer just like before problem. So you can see actually in half an hour we solved more than 10 questions we solved, that is with explanation, and each question I explained at least twice I explained. So that means you can answer within 30 minutes, you can answer 30 questions binomial theorem. So this is very simple topic, you can learn nicely, and questions will be asked based on basic concept only in GMains especially. Okay, thank you very much.